Welcome, space explorers, to G Fun Facts Online, your portal to the most mind-bending wonders of the universe. Today, we're journeying to our closest stellar neighbor, not to visit the star itself, but its captivating companion, the exoplanet Proxima Centauri b. Imagine an Earth-sized world, tantalizingly close, orbiting within the habitable zone of its star. A place where liquid water, the elixir of life as we know it, could potentially exist. But hold on, because the story of Proxima b's habitability is a thrilling, complex puzzle, and scientists are racing to piece it together using cutting-edge climate models. Are you ready to dive in? First, let's get to know the star of the show. Or rather, the star that Proxima b orbits, Proxima Centauri. This isn't a sun like ours. Proxima Centauri is a red dwarf, much smaller, cooler, and dimmer. This dramatically changes the game for any orbiting planets. The habitable zone, that Goldilocks region where temperatures are just right for liquid water, is snuggled up incredibly close to the star. Proxima b zips around its star at a distance of only about 0.05 astronomical units. That's just 5% of the distance between Earth and our Sun. It completes a year, one full orbit, in a dizzying 11.2 Earth days. Imagine birthdays every week and a half. Now, this cozy orbit puts Proxima b in the temperature sweet spot, but there's a fiery catch. Proxima Centauri is a flare star. This means it frequently unleashes intense bursts of electromagnetic radiation and energetic particles. These flares are monstrously powerful compared to its overall energy output, far more so than our sun's tantrums. Think of it as living next door to a cosmic fire breather. This constant bombardment could be a death sentence for any atmosphere Proxima b might have, either stripping it away entirely or drastically changing its chemistry. Recent observations have detected hundreds of these flares, some lasting mere seconds but packing a serious punch. This intense space weather is a huge question mark hanging over Proxima b's potential for life. So, what do we know about Proxima Centauri b itself? It was discovered back in 2016, and we found it using the Doppler spectroscopy method, which detects the tiny wobble of a star caused by an orbiting planet's gravity. It's estimated to have a minimum mass around 1.1 to 1.3 times that of Earth. Its exact size, or radius, is still a mystery, which makes figuring out what it's made of a bit tricky. Is it a rocky world like ours? Or could it be an ocean planet, completely covered by a deep, global ocean, perhaps even 200 kilometers deep? Without an atmosphere, its surface would be a frigid -39 degrees Celsius. But, and this is a big but, an atmosphere could change everything, acting like a planetary blanket. Now, let's talk about the gauntlet of challenges Proxima b faces on its path to habitability. First up, tidal locking. Because it's so close to its star, Proxima b is likely tidally locked. This means one side constantly faces the star, experiencing perpetual daylight, while the other side is plunged into eternal night. Talk about extreme temperature differences. Imagine one side scorching hot and the other frozen solid. However, there's a glimmer of hope. Some models suggest that if Proxima b has a slightly eccentric orbit, it might be caught in a different kind of spin, like Mercury's 3:2 resonance, avoiding a perfect lock. Even if it is tidally locked, a thick atmosphere or an ocean could act like a global circulatory system, shunting heat from the day side to the night side, potentially making some regions more temperate. Then there's the relentless onslaught of those stellar flares we mentioned. The X-ray and extreme ultraviolet radiation blasting from Proxima Centauri could have stripped away any atmosphere Proxima b started with, especially early in the star's life. Our neighbor receives about 30 times more extreme UV radiation and a whopping 250 times more X-rays than Earth. Could an Earth-like atmosphere survive that? Many models say no, suggesting it might have been lost to space within millions of years. But we don't know how much atmosphere it started with, or what it was made of. A strong planetary magnetic field, like Earth's, could offer some protection, but we have no idea if Proxima b has one. It's all a giant cosmic what-if. And that brings us to the atmosphere itself. If it even has one. If its original atmosphere was lost, perhaps volcanic activity could have created a new, secondary one, likely rich in carbon dioxide, The presence of enough greenhouse gases is absolutely crucial. Scientists are exploring all sorts of atmospheric scenarios: high oxygen, high carbon dioxide, something more Earth-like. Recent studies even highlight the importance of ozone, not just for blocking harmful UV rays, but also for influencing atmospheric temperature and wind patterns. And what about water? How much water did Proxima b start with? Did it all get boiled away or broken down by radiation? Some models suggest catastrophic water loss, leaving a dry husk or a world with an oxygen atmosphere not from life but from split water molecules. It's a cosmic detective story with many missing clues. So how do scientists try to figure out what this alien world might be like? They use super sophisticated 3D general circulation models, or GCMs. These are basically the same kind of computer programs used to predict Earth's future climate, but adapted for an exoplanet. These models simulate everything: radiation from the star, how an atmosphere would circulate, ocean currents, the effect of clouds, and greenhouse gases. And what have these simulations revealed? Well, for a tidally locked planet with water and an atmosphere, a fascinating scenario often emerges: the eyeball Earth. Picture this: on the star-facing side, a large area of open liquid water, the pupil of the eyeball, surrounded by a ring of ice. It sounds bizarre, but it's a plausible outcome. Dynamic oceans are key here. They could transport heat from the scorching day side to the freezing night side, potentially creating larger areas of liquid water, even if it's super salty. Clouds also play a massive role. Simulations suggest a thick cloud layer could form on the day side, reflecting stellar radiation and acting like a sunshade, keeping things a bit cooler. This cloud shield, along with ocean currents, helps stop the atmosphere from freezing out and collapsing on the dark side. The composition of the atmosphere is also a game changer. The amount of greenhouse gases like carbon dioxide can make all the difference. Models show that even with tidal locking, a decent amount of CO2 could keep the night side from becoming an ice ball, especially if there's an ocean to help move heat around. Scientists have even modeled different rotation states, not just tidal locking, showing that other spin patterns could lead to different habitable zones, like a permanent tropical water belt on an ocean planet. Oh, and expect it to be windy. Simulations predict super strong winds flowing from the hot day side to the cold night side. Interestingly, some newer studies suggest that even the extreme gravity tugging on Proxima b wouldn't mess too much with its surface weather in the long run. Tidal locking is the main climate shaper. Of course, the ultimate question is there liquid water? While models can show us where water could be liquid, actually finding it, or even finding an atmosphere, from light years away is an incredible challenge. But scientists are not giving up. They're looking for telltale atmospheric signatures. If Proxima b has an atmosphere, future supertelescopes might be able to spot gases like oxygen, ozone, methane, and carbon dioxide, potential biosignatures, hints of life. For example, finding methane, which lasts longer under Proxima Centauri's harsh UV light, alongside oxygen, could be a very exciting sign. But let's be clear, directly seeing Proxima b is almost impossible right now because it's so close to its bright parent star. It's like trying to spot a firefly next to a searchlight. However, its closeness to Earth makes it a prime target for the next generation of observatories. The James Webb Space Telescope, or JWST, is a major player. It might be able to observe how the planet's brightness changes as it orbits, giving us the first clues about whether an atmosphere exists and how heat is transported. It could even detect certain molecules. Then there are the future giant ground-based telescopes like the Extremely Large Telescope, or ELT. These behemoths might actually be able to directly image Proxima b and analyze its light for molecular signatures. Imagine that, getting a direct glimpse of an alien world's air. The study of Proxima Centauri b is a story that's still being written. Our understanding is evolving almost daily as climate models get more sophisticated, adding in more complex physics and chemistry. Yes, there are huge challenges to its habitability, especially those violent stellar flares and the big unknowns about its atmosphere and water. But Proxima b remains one of the most compelling places to look for life beyond Earth. It's a crucial test for all our theories about what makes a planet habitable. Is it a barren, irradiated rock? A water world with strange, salt-loving life? Or something else entirely? Something we haven't even imagined? Whatever the answer, exploring Proxima Centauri b pushes the limits of our knowledge and fuels our relentless quest to find our place among the stars. It's a testament to human curiosity at its finest. Thanks for joining us on this cosmic journey with G Fun Facts Online. We hope you're as fascinated by Proxima Centauri b as we are. Don't forget to subscribe for more amazing facts from across the universe. Until next time, keep looking up.